Welcome to the course on problem solving through C. So this is programming in C. The subject code is 23 CPI 15B. So let's start discussing about module 1. Module 1 is all about module 1 is all about introduction to computers. These are all the contents in this module. Introduction to computers, its definition, characteristics of computers, stored program concept, history of computers, classification of computers, applications of computers, basic organization of computers, and in second part we have programming basics and overview of C, that is introduction, problem solving, introduction to C, basic structure of C program, programming style. So first we'll start with definition of a computer. A computer in simple terms can be defined as an electronic device that is designed to accept the data, perform the required mathematical and logical operations at high speed, and output the result. So it consists of so many things like system unit or the CPU, output devices like monitor, printer, input devices like mouse, keyboard, and there is a mass storage device. So coming to the uses of computer, here we can see what are the uses of computer. Like it can be used for so many purposes. Like it can be used for business, science, government, health and medical, education, industry, banking, entertainment, training, arts, sports, robotics, safety and security, publishing, weather forecasting, communication. So there are so many applications, there are so many fields where the computer can be used. No, what is the use of this computer is like it is these are the some of the uses of computers, like where all it can be used. And coming to the computers, like earlier computers were large in size. It required entire room for installation. It consumed enormous amount of power, and it was too expensive that it could not be bought by each and everyone who wants to access it to use for commercial purpose, used for limited task. It could not be used for all the applications or in all the fields earlier days, as its size is too large and it's limited for some particular tasks. So as with technological advancements, the size of the computers became smaller and their energy requirements reduced immensely. So this opened the way for adoption of computers for commercial purposes. And there are different types of computers, and these different types of computers are based on size, purpose, and working principle. These days, computers have become so prevalent in the market that all interactive devices such as cellular phones, global positioning system, GPS units, portable organizers, automated teller machines, and gas pumps, all these works with computers. So there is no field or no places such as we can say that there are no computers, where no computers are used. So in every field, in every place nowadays, the computers are required, and its presence is very much useful. So coming to the characteristics of computers, computer, as we know, it's an electronic device that performs a function based on a given set of instructions known as a program. A computer, it accepts data, processes it, and produces information. Here, data refers to some raw fact or figure, and information implies the processed data. Here we have some of the characteristics of the computers, as we can see, like it is economical, and it also says that no IQ, because computers have no IQ. It's a programmer who writes the coding, who does all the programming part and feeds it to the computer, and the computer follows that. So the one more characteristics of computer is large memory. So one advantage of having a large memory is like many things can be stored. And coming to the coding part, like if you want to run some software, or if we want to code something, the memory is required. So in that case, the large memory is an advantage, and it's one of the characteristics of a computer. Accuracy: when we're performing some operation, the or the result accuracy of the result is also matters a lot, and it becomes very important. So accuracy is very important, and speed is one of the characteristics of the computers, as when we're executing some program, or when we're running some application, if it is very slow, then the purpose of having the computer, using it, it doesn't serve the purpose. So when we are running the code, when we are running some program, if the speed of the computer is of good speed, then we can do the tasks fast, and we can complete more number of tasks in a very less time. So the speed is one of the characteristics of computers. Versatility is also one of the characteristics of computer. Diligence, automation are the characteristics of computers. Speed. Computers can perform millions of operations per second, which means that data that may otherwise take many hours to process is output as information in the blink of an eye. So the speed of computers is usually given in nanoseconds and picoseconds, where 1 nanosecond and 1 picoseconds is equal to like 1 into 10 power minus 9 seconds, and pico means it's 10 power minus 12 seconds. And accuracy: computer is a very fast, reliable, and robust electronic device. It always gives accurate results, provided the correct data and set of instructions are input to it. Hence, in the event of an error, it is the user who has fed the incorrect data or program is responsible. This clearly means that the output generated by a computer depends on the given instructions and input data. If the input data is wrong, then the output will also be erroneous. In computer terminology, this is known as garbage in, garbage out, GIGO, GIGO. Automation. Besides being very fast and accurate, computers are automatable devices that can perform a task without any user intervention. The user just needs to assign the task to the computer, after which it automatically controls different devices attached to it and executes the program instructions. Diligence. Unlike human, computers never get tired. It never gets tired of repetitive tasks. So it can continually work for hours without creating errors. Even if a large number of executions need to be executed, each and every execution requires the same duration and is executed with the same accuracy. Versatile. Versatility is the quality of being flexible. Today's computers are used in our daily life in different fields. For example, they're used as personal computers for home use, for business oriented tasks with the forecasting, maybe space exploration, teaching, railways, banking, medicine, and so on, indicating that computers can perform different tasks simultaneously. On the PC that you use at home, you may play a game, compose and send emails, listen to music, etc. Therefore, computers are versatile devices, as they can perform multiple tasks of different nature at the same time. Memory. Similar to humans, Computers also have memory. Just the way we cannot store everything in our memory and need secondary media, such as notebook, to record certain important things, computers also have internal or primary memory, storage space, as well as external or secondary memory. While the internal memory of computers is very expensive and limited in size, the secondary storage is cheaper and of bigger capacity. The computer stores a large amount of data and programs in the secondary storage space. The stored data and programs can be retrieved and used whenever required. Secondary memory is the key for data storage. Some examples of secondary devices include floppy disks, optical disks, and hard disk drives and pen drives. When data and programs have to be used, they are copied from the secondary memory into the internal memory, and it often known as random access memory. One more characteristics of the computer is no IQ. Although the trend is today is to make computers intelligent by inducing artificial intelligence in them, they still do not have any decision making abilities of their own, but they need guidance to perform various tasks. Economical. Today, computers are considered as short term investments for achieving long term gains. Using computers also reduces manpower requirements and leads to an elegant and efficient way of performing various tasks. Hence, computers save time, energy, and money. When compared to other systems, computers can do more work in lesser time. For example, using the conventional postal system to send an important document takes at least 2 to 3 days, whereas same information when sent using the internet through email will be delivered instantaneously. So, coming to the stored program concept, all digital computers are based on the principle of stored program concept, which was introduced by Sir John von Neumann in the late 1940s. The following are the key characteristics or features of this concept. Before any data is processed, instructions are read into the memory. Instructions are stored in the computer's memory for execution. Instructions are stored in binary form using binary numbers only. Zeros and ones means it's a sequence of zeros and ones. Processing starts with the first instruction in the program, which is copied into a control unit circuit. The control unit executes the instructions. Instructions returned by the users are performed sequentially until there is a break in the current flow. Input or output and processing operations are performed simultaneously. While data is being read or written, the central processing unit, which we call it as CPU, it executes another program in the memory that is ready for execution. So John Macaulay, an American physicist, and Presper Eckert, an American engineer, further contributed to the stored program concept to make digital computers much more flexible and powerful. As a result, engineers in England built the first stored program computer, Manchester Mark I, in the year 1949. They were shortly followed by the Americans who designed EDVAC in the very same year. Today, a CPU chip can handle billions of instructions per second. It executes instructions provided both the data and instructions are valid. In case either one of them or both are not valid, the computer stops the processing of instructions. So here we have a block diagram for von Neumann architecture, uh, which shows shared memory for instructions and data, figure A, and figure B shows the separate memories for instructions and data. In the first figure, figure A, we can see that we have processor and the main memory. And it has two bus. One is address bus, which carries the addresses, data bus that carries the data and instructions. As we can see, the data bus is bidirectional, but the address bus is unidirectional from processor to main memory. Whereas in figure B, we have instruction memory, processor, and then data memory. So from processor, instruction address goes to instruction memory, data address goes to data memory. So the data is received from instruction memory to the processor and data memory also. Like the data can be read or written to the processor and the data memory. Coming to the history of computers, around 300 BC, the abacus was an early aid for mathematical computations and was designed to help humans' memory while performing calculations. A skilled abacus operator can add and subtract with the same speed as that of a person performing the same calculation using a hand calculator. So the invention of abacus is often wrongly attributed to China. Well, it was used by the Babylonians even in 300 BC and is still in use today. In 1822, English mathematician Charles Babbage designed a steam driven calculating machine that could compute tables of numbers. Though the project failed as he could not complete the construction of the engine, it laid the foundation for the first computer. 1890, Herman Hollerith, an American inventor, designed the punched card system to calculate the 1880 census. The system completed the task in 3 years, saving the US government $5 million. Later, Herman established a company that we today known as IBM. 1936, British mathematician Alan Turing introduced a universal machine called Turing machine, which is capable of computing anything that is computable. The central concept of the modern computer is based on this machine. John Vincent Atonasov, a Bulgarian American physicist, his graduate student Clifford Berry at Iowa State College designed a Berry computer ABC that could solve 29 equations simultaneously. It was the first time a computer could store information in its main memory. In 1943 to 1944, John Macaulay and Percival Rickard built the electronic numerical integrator and calculator, which is considered as the grandfather of digital computers. It filled a 20 by 40 feet room and had 18,000 vacuum tubes. In 1946, Macaulay and Presper designed the UNIVAC, which was the first commercial computer for business and government applications. In 1947, William Shockley, John Bardeen, and Walter Brattain of Bell Laboratories invented the transistor. Soon, vacuum tubes in computers were replaced by transistors. Grace Hopper developed the first computer language, COBOL. The Fortran programming language was developed in 1954. In 1958, Jack Kilby of Texas Instruments and Robert Noyce at Fairchild Semiconductor Corporation separately invented integrated circuit, which is commonly known as a computer chip. In 1964, Douglas Engelbart developed a prototype of the modern computer with a mouse and a graphical user interface. This was a remarkable achievement as it shifted computers from a specialized machine for scientists and mathematicians to general public. 1969, Unix operating system was developed at Bell Labs. It was written in the C programming language and was designed to be portable across multiple platforms. Soon it became the operating system of choice among mainframes at large companies and government entities. In 1970, DRAM chip was introduced by Intel. 1971, Alan Shugart, with his team in IBM, invented the floppy disk, which allowed data to be shared among computers. 1973, Robert Metcalf, a research member at Xerox, developed Ethernet for connecting multiple computers and other hardware. 1974 to 77, personal computers started becoming popular. 1975, Paul Allen and Bill Gates started writing software for the Altair 8800 using the new BASIC language. On April 4, they both formed their own software company, Microsoft. 1976, Steve Jobs and Steve Wozniak started Apple Computers and developed Apple I, the first computer with single circuit board. 1977, Apple II was launched and that offered color graphics and incorporated an audio cassette drive for storage. 1978, WordStar, a word processor application, was released by MicroPro International.